Hello everyone. My topic for presentation is process migration from the chapter process management. Let us look at the what is meant by process management. In conventional, that is centralized operating system, process management deals with mechanism and policies for sharing the processor of the system among all processes. In a distributed operating system, the main goal of the process management is to make the best possible use of the processing resources of the entire system by sharing them among all processes. Three important concepts are used to achieve this goal, that is, process allocation, process migration, and threads. Process migration: relocation of a process from its current location to another node, and process may be migrated either before it starts executing on a source code known as non-primitive process migration, and second one is or during the course of its execution known as a primitive process migration. Now let us look at the flow of execution of migration process. We can see freezing time, source node, destination node, execution suspended, process P1 execution, transfer of control from source node to destination node, and where is execution is resumed, and we can see process P1 in execution. In this we need to execute the processor P1. Primitive process migration is costlier. Process migration policy: selection of a process that should be migrated, selection of the destination node to which the selected process should be migrated. Process migration mechanism: actual transfer of the selected process to the destination node. Desirable features of good process migration mechanism, that are transparency, minimal interference, minimal residual dependency, efficiency, robustness, communication between co-processor of a job. Transparency. Level of transparency: in this we have two subpoints, that are object access level, system call, and inter-process communication level. In object access level, we have minimum requirement for a system to support non-primitive process migration facility, and second one is requires transparent object naming and locating. In system call and inter-process communication level, we have for migrated process, system calls should be location independent. Transparency must be provided to support preemptive process migration facility. Minimal interference: in migrated of a process should cause minimal interference of a progress of the process involved, achieving by minimizing the freezing time of the process being migrated. In minimal residual dependency, known residual dependency should be left on previous node. And in efficiency, we have minimum time required for migrating a process. In robustness, the failure of a node other than the one on which a process is currently running should not in any way affect the accessibility or execution of that process. Last one is communication between co-processor of a job. To reduce communication cost, it is necessary that co-processes are able to directly communicate with each other irrespective of their locations. Process migration mechanism: four major activities, that are freezing the process on its source node and restarting it on its destination node, transferring the process's addresses space from source node to destination node, forwarding message meant for migrant processes, handling communication between cooperating processes that have been separated as a result of process migration. Mechanism for freezing and restarting a process. Freezing the process: the execution of the process is suspended and all the external interaction with the processes are deferred. Here we have some issues that are as follows: immediate and delayed blocking of the process, fast and slow input-output operations, information about open files, reinstarting the process on its destination node, immediate and delayed blocking of the process. In this we have, if the process is executing a system call but is sleeping at an interruptible priority waiting for a kernel event to occur, it can be immediately blocked from further execution. Fast and slow input-output operation. In this we have process is frozen after the completion of all input-output operations like disk access. And in information about open files, we have includes name and identifier of the file, the access modes and the current position of their file pointers. Reinstating the process on its destination node. In this, we have the on the destination node, an empty process state is created. In address space transfer mechanism, we have address space transfer mechanism like process states, processes address space from the source node to the destination node. Now, we should know the mechanism for address space transfer. They are as follows. They are of three types: total freezing, free transferring, transfer on reference. First, let us look at the total freezing. A process execution is stopped while its address space is being transferred. We can see in below diagram the mechanism for total freezing. That is, in this we have time, source node, destination node. As we have seen earlier, here we have the freezing time, execution suspended, migration decision made, transfer of address space, and the execution resumed. In this, we can see the process which is going on has been freezed, and that's why it is called the total freezing mechanism. Now, let us look at the pre-transferring. It is done as an initial transfer of the complete address space, followed by repeated transfers of the page modified during the previous transfer. As we can see, pre-transfer mechanism, here we have likewise time, source node, and destination node. And the execution suspended, transfer of address space, execution resumed, and freezing time. Transfer on reference. The process address space is left behind on its source node, and as the relocated process executes on its destination node. Pre-transfer mechanism. Here we can see on-demand transfer of address space, migration decision made, execution suspended, execution resumed. Means execution is resumed on demand of transfer of address space, as shown in the diagram. Now let us look at the message forwarding mechanism. In a moving up process, it must be ensured that all the pending reroute and the future message arrives at the process's new location. What is the mechanism behind it? The mechanism are of four types: mechanism for sending the message, origin site mechanism, link traversal mechanism, link update mechanism. Mechanism for handling co-processes. To provide efficient communication between a process and its sub-processes which might have been migrated on different nodes, mechanisms are, in this we have two mechanisms that are disallowing separation of co-processes and home node or origin site concept. Firstly, we should look at the first one, that is disallowing separation of co-processes. That is, easiest method of handling communication between co-processes is to disallow their separation. And second one is home node or origin site concept, used for communication between a process and a sub-process when the two are running on different nodes. Process migration in heterogeneous system. It is the subtopic in the process migration. All the concerned data must be translated from the source CPU format to the destination CPU format before it can be executed on the destination node. A heterogeneous system having n CPU systems must have n into n-1 piece of translation software. Handles problems of different data representations such as characters, integers, and floating point numbers. In this diagram example, the need for 12 pieces of translation software requires in a heterogeneous system having four types of co-processes. That is processor 1, processor 2, processor 3, processor 4. We can see that 12 different pieces of translation is done from processors of type 1, 2, type 3 and 4 respectively. And here we can see the need for only 8 pieces of translation software in a heterogeneous system having 4 types of co-processes when the EDR mechanism is used. Handling exponent. The number of bits for the exponent varies from processors to processor. The EDR have at least as many bits in the exponent as the large exponent. Overflow or underflow can be managed upon conversion from the external data representation. Handling the mantissa. Suppose processor A uses 32 bits and processor B uses 64 bits. No problem from A to B migration. Half precision problem from B to A migration. Solution. The external data representation must have sufficient precision to handle the largest mantissa. Advantages of process migration. They are reducing average response time of processes, speeding up individual jobs, gaining higher throughput, utilizing source effectively, reducing network traffic, improving system reliability, improving system security. Hope this presentation would be helpful. Thank you.